My name is Jonathan Hicks. We're doing angle facts. Now there are quite a few facts to do with angles that you need to know. A lot of problems in geometry require that you know these facts, so they're well worth learning. Now if you don't know anything about angles at all, go and watch the angles intro video first and that'll cover the basic concepts. So I'm going to assume you're familiar with the basics. Just very quickly then, angles in a full circle, you should know add up to 360 degrees. That's the first fact you should be aware of. Next then, angles on a straight line. So if I have a straight line here and another line that meets it at a point, then these two angles are going to add up to 180 degrees. Yep, an angle on a straight line, so halfway around the circle to there, is going to add up to 180 degrees. And if you have two angles that add up to 180 degrees, sometimes we say that they're supplementary. So that's a word you should be familiar with. You probably don't need to memorize the definition, but at least be aware that this exists and you can look it up. So supplementary means that they add up to 180 degrees. So these two angles will be supplementary, but any pair of angles in any situation that add up to 180 degrees would be supplementary. So in this case, if this one was 135 degrees, then you can work out what this angle is going to be. Obviously in this case, it's going to be 45 degrees because these two things need to add up to 180 degrees. Next one then, if you have a right angle here, now usually you draw a box in the corner. I'm not going to do that, you'll see why in a second. But if we say that's a right angle, and if I then split that in two, so I've got one arc there and another angle here, so two angles which add up to 90 degrees, then we say that they are complementary. This is complementary, not complimentary. You're not saying how nice the hair looks. You're saying that these two angles here add up to 90 degrees. So again, in any situation, any two angles that add up to 90 degrees are complementary. So those are some important definitions you should be aware of. We're going to be using those quite a bit. But obviously a right angle is 90 degrees, angle on a straight line is 180, and a full circle is 360. Those are the basic facts you should be aware of. Right, next up then, we're going to be using some of these facts in various different situations. And the first situation is fairly straightforward. If you have two straight lines that cross, so one straight line and another straight line, then that forms some angles at the point where they cross. So we get one angle here, another one here, and then another angle on the top and the bottom. And these are said to be vertically opposite angles. As in, the ones that are opposite each other, whenever you have two straight lines that cross, are always the same. So these two angles have to be the same. Perhaps if we make those into double arcs so that you can see that clearly. So those two are the same, and those two would be the same as well. Obviously they're not all the same, but the opposite ones, as I say, they're called vertically opposite, are the same. Now there's a reason why they're the same, and it all has to do with this angles on a straight line adding up to 180 degrees. If you imagine if I cover up that bottom bit there, which is a bit tricky for me to do, these two angles here are on a straight line, so they're going to add up to 180 degrees. So whatever that one is, this is 180 degrees minus that one. Now if I also then look at that straight line there and these two angles, these have to add up to 180 degrees as well. So whatever I needed to add up to that one to make 180 degrees, i.e. that angle, has to be the same here, because those two have to add up to 180 degrees just like those two do, because they're both on straight lines. So for that reason, these two opposite ones have to be the same. You can do a similar argument with the ones at the side, but all you need to remember here is that angles that are opposite each other when two straight lines cross are always the same. Okay, so vertically opposite angles are equal. Let's write that down so you can see how it's spelt. It's vertically as in vertically straight up, opposite because they're across from one another, and those angles are equal. So that's quite an important fact to do with angles that you should be aware of. This situation where you have two lines that cross happens a lot, so be aware of that one. Okay, that's our first angle facts really. The next set of angle facts are all to do with parallel lines. So I'm going to draw a picture up here, and then we're going to discover a few facts about the picture. So parallel lines, if you remember, if I've got two lines like that which are parallel, that means they're always the same distance apart all the way along. They're straight lines, they never get closer together, and they're never going to get any further apart. They're always the same distance along, same distance apart. And the way you indicate that in maths is you put a little arrow on each of these to indicate that those are parallel lines. Now if I had another line, another straight line, that crossed that, like that, then we have a whole bunch of angles that are being formed here. So I've got 4 angles here, and another 4 angles here. And just like with the vertically opposite angles, you've got 2 straight lines that cross here, so immediately you can say that these 2 angles are going to be the same, and those 2 angles are going to be the same as well. You can do the same thing at the top there, but there are also, and this is the reason I've drawn this picture, various facts that link these 4 angles with these 4 angles. As it turns out, there aren't very many angles here at all, as in, if you know this one, you can work out all of the other angles. There's only actually 2 different types of angles that you're going to have in this situation. But let me explain the facts. These all have names, but I find it much easier to remember the pictures. So I'm going to show you a picture way of remembering this, a sort of letter shape to remember, and I'll give you the names as well. So firstly then, you have what are called corresponding angles. Corresponding. And corresponding angles always make what I think of as an F shape. So if I draw an F shape like this, the 2 bars of the F are the parallel lines, and then the 2 angles that sit underneath those bars are said to be corresponding angles. And corresponding angles are always the same. I should say that there are various different ways you can orient the F shape as well. So for example, you could turn it upside down and it still works fine. These 2 angles will be the same. Those are still corresponding angles. You could have it backwards, like that. Again, the 2 angles that sit underneath the bars will be the same. Or you could have it backwards and upside down, in which case those would be the 2 angles that would be the same. So it doesn't matter which way around it goes. I mean, effectively you can just sort of turn your head round and you will see the F shape. But any angles that sit underneath the bars of an F shape like that, where the 2 bars on the F are the parallel lines, those will be corresponding angles, okay? And these angles are always equal. So corresponding angles are equal. So on the picture up here, can we find any F shapes? Well, if I sort of go over that, and that's there, hopefully you can see that makes an F shape, which means that this angle here and this angle here have to be the same. Okay, the next fact we need, the next type of angles are called alternate angles. And again, alternate angles are always going to be the same, but the shape that I remember of this one is a Z shape, or in the States you might call it a Z shape. But it looks like that. So the 2 angles that sit in the crux of the arms of the Z are going to be the same. They're said to be alternate angles. Again, you can flip it around, so you can have a backwards Z shape, which looks more like an S shape, like that. Those 2 angles are going to be the same. You can also have a funny sort of stretched out one. If you take the 2 arms and pull them, then you're going to have something that looks like that. And again, these 2 angles are alternate, they're the same. And you can flip that round and do it that way. So those 2 angles will be the same. So these are all the different configurations, but alternate angles are also equal. On the picture up there then, if I were to start up here, this one's fairly clear to see. So if I do a wavy line there, and a wavy line here, and a wavy line there, you can see there's a Z shape there. So these 2 angles, that one, if I do a double arc, and that one will be the same. Equally though, if I took this configuration, you could see I could go there, down and across, which means that that one must be the same as that one as well. Which makes sense because these 2 angles were the same because they were corresponding. These 2 are the same because they're alternate. So these two must be the same, and because they're vertically opposite, that confirms yes, they must be the same. So in fact, this one we can work out from this one has got to be the same, yeah, because those two are vertically opposite. So I could do a double arc in there. The last type that you need to be aware of then is interior angles. And interior angles are like a C shape. So something like that, and it's the two angles that obviously sit inside the C shape. You can have it backwards, something like that. And interior angles are not equal. So corresponding angles are equal, alternate angles are equal. Interior angles, though, are supplementary. Supplementary. And if you remember from earlier, that means that they add up to 180 degrees. So for example, you can make your C shape there. Yep, these two angles that sit inside the C here, they must add up to 180. And again, because we saw that this angle is the same as this angle, if I cover up the bottom bit there, these two angles must add up to 180 because they're on a straight line. So if this one's the same as this one, then those two must add up to 180 as well. So that's why interior angles always add up to 180 degrees. It's why they're always supplementary. But again, that means the ones on the other side, the double angle there and the single one there, those two will add up to 180 again. And you can see them matching with the single one there. Because they're on a straight line, they're going to add up to 180. So actually, if I just redraw this without all the squiggly lines all over it, you can see there aren't very many angles here that you need to worry about, as I was saying. Those are our parallel lines and the line that crosses it. So if we know what that one is, you can work out what that one is. It's the vertically opposite angle, must be the same. You can work out what this angle is, because it adds up to 180 degrees on a straight line. And then this one is going to be vertically opposite. So you can work out what that one is. And then you can use the corresponding fact, the alternate fact, the interior fact. Whichever one you choose to use will get you from one of these angles to one of these angles. So for example, if you use the alternate angle fact in the Z shape, that means that this one, you have a Z there, so that one inside and that one inside have got to be the same, which means that this one is vertically opposite, so that's got to be the same. These two must add up to 180, so this has got to be the same as this one. Or you can use your Z shape again the other way around. So that's going to be the double arc, and again vertically opposite, that's going to be the double arc as well. So with all the angles here, there are actually only two different angles. There's the single arc angle, which is the same as that one and that one and that one, and then there's the double arc angle, which is the same as that one and that one. And as I say, once you figured out what one of them is, if I tell you this angle was 45 degrees, for example, you could work out all the other angles fairly quickly with these facts. So these three situations, the corresponding angles, alternate angles, and interior angles, which I remember with the different shapes. I don't tend to remember the names too much, so don't worry about that. If you know the shapes, you can work out which angles are the same, and then you can solve the problems. So just remember that F shapes give you equal angles, so do Z shapes, but C shapes give you supplementary angles. They add up to 180 degrees. But this only applies for parallel lines. If you don't have this situation with the two parallel lines and the lines that cross it, then you can't be making the shapes anywhere else. It only works if you've got parallel lines. Parallel lines do crop up quite a lot though in various shapes. I mean, if you've got a parallelogram, the lines are parallel, or a rectangle, again you've got the parallel lines. There are lots of situations where you will find these parallel lines appearing. So they do tend to be quite useful. And those are the main facts you should be aware of, as well as the vertically opposite angles being equal thing. I'm going to do another video which I show you how to use these facts to solve problems, but those are the main ones you should be aware of.